system. In today's session, we are going to continue with the topic process synchronization. Myself, Kunal Panchal, your instructor. In this particular session, we are going to discuss one classical problem of process synchronization, which is nothing but a producer-consumer problem. And this problem we are going to solve with the help of semaphore. So let us discuss what is the producer-consumer problem first. So as far as producer-consumer problem is concerned, there are two important processes we can say. One is producer and second one is consumer. Like for example, a producer will produce one software and that software would be consumed by the consumer. Okay, so by having this consideration, we can understand at a particular moment of time, either producer can execute a task or consumer can execute a task. Means to resolve the problem of producer consumer, we are going to take one buffer of n size, and this buffer you can see in this particular figure. This buffer would be treated as critical section, and you know very well what is critical section and how we can solve the critical section problem with the help of semaphore. We have already understood in the previous sessions. Okay, so to solve the critical section problem means what this buffer would be considered as a critical section. It means at a particular moment of time, either producer can execute a task or consumer can execute a task. Simultaneous operation of producer and consumer cannot be possible in critical section. Means what? This needs to be executed in a mutual exclusion fashion. Okay, so that we want to achieve first. Okay, so to resolve this issue, okay, we have three semaphore. As you know very well, to solve the critical section problem, we need to initialize the semaphore value by 1. So first, S is nothing but 1 to solve the critical section problem. Second is the underflow conditions and overflow conditions we need to check. Means if buffer is empty, underflow condition, that is nothing but underflow condition. In that case, consumer operation or consumer cannot perform its task because there is no element is there in the buffer or say in array. So when we have underflow condition, in that case consumer cannot perform a task. Same way, when we have overflow condition, means what? All the cells are occupied. In that case, producer cannot produce something. So by having these three considerations, one is critical section problem, one is underflow condition, third one is overflow conditions. So to resolve these three problems, okay, or we can say scenario, we need to have three semaphore for each situation. One is for critical section, second one is for underflow condition, and third one is for overflow condition. So semaphore E stands for empty slots. So initially, value of E, empty slots are n, because at initial position the buffer is empty. So empty slots are n, and initially the semaphore of value F is nothing but 0. Means there is no element in the buffer. So definitely the full slots are 0. So these are the initial values that we need to consider. Okay. So by having this consideration, let us discuss first the producer problem, in which, as you know very well, by having this figure that I have carry forwarded by modifying certain things. So let us discuss first producer problem. Then we will discuss consumer. So as far as producer is concerned, you can see this is nothing but set of lines or we say code in producer logic. Okay. So what is the task of producer? Producer will produce something. It means what? Just like insertion. Insertion operation will be performed by the producer in the data structure called, we can say one data structure called array in this case. Buffer would be considered as array as well. Okay. So when producer producing something, so definitely in this case what we will do, so we have initialized the value of E, S and F. So initial value of F is 0, initial value of S is 1 and initial value of empty slot is 5. So this is the initial value that I have set. Okay. Now let us execute the code of producer. So what will happen in the case of producer? While T means what? We have while loop in this case, and while condition is true means what? This loop can be executed n number of times. Okay. So the first statement is produce means what? This is nothing but a theoretical sentence or statement we have. This is nothing but theoretical statement we have produced. It means what? Producer will start its functioning. Okay. Now the first statement that producer needs to execute it is nothing but wait on E. Means wait on E means E is nothing but empty slots. How many empty slots we have? 5 empty slots we have. Let us consider the size of buffer is 5. Okay. So by consideration of 5 value, so wait of E can be executed. Now the value becomes 4 because wait operation will reduce the value of E by 1. Okay. Then next statement is wait of S. Wait of S means S is nothing but a semaphore which is intended for to achieve critical section problem. Yes. Yes. So wait on S means definitely why we are using this S to avoid the critical section problem. So it means what? At a time only one process can enter into critical section. So initial value of S was 1. Now wait on S means it will be decremented by 1. Now once the producer is okay, say producer is producing something, at that time no other consumer can consume something. Yes. So that's why we have used this semaphore. Once the value is decremented, then producer will append something in the buffer. Means what? It will insert something. So first of all, say for example, you can see in this case X is inserted. X is inserted by the producer. So once append is successfully executed, then signal on S. Signal on S means now once appending operation insertion is completed, now the another producer can produce something. So that is the reason why we have executed signal on S. Okay, signal on S means now again the value of S becomes 1, so that other process can do its task. Okay, and then finally signal of F. Signal of F means what? Now F is for what? Full slot. So initially the full slot value was 0. Now it will be incremented by 1 because now we have inserted one element in the array. So now the F value is 1. Now another value needs to be added by the producer. So again this set of code will be executed. Again wait on E would be performed. Again value will be 3 in this case. Wait on S would be performed. Again the value will be 0 so that other process cannot enter into critical section. Then appending will be performed means what? Now in this case Y element is inserted in the buffer. Then signal on S means what? Again I need to increment the value of S by 1. So it will be 1 in this case. Yes, and signal of F means now the full slots are what 2 instead of 1. Okay, so in this way producer logic works. Okay, so this is all about producer logic. Now you can see in the producer logic the 3 statements I have highlighted with the help of yellow color. These statements are specifically for to achieve critical section. Or we say these 3 statements works in a mutual exclusion fashion only. Means what it provides a security. Means what at a particular moment of time, if one process is doing its execution, no other process can enter into a critical section. So that is the reason why I have highlighted this set of code in yellow color. Now let us discuss the next logic, which is nothing but consumer logic. So in the case of consumer logic, again what will happen in this case? We have inserted X and Y. Now in this case what we need to do is consumer will, it means what delete operation needs to be performed by the consumer. So again while T, then wait on F. Now full slot becomes in this case what the full slot value would be, initially it was 0, but after doing producer logic we have the value of 2 as far as full slot is concerned. Now if you want to remove, or can say if you want to delete one element from the array or can say buffer, so weight of F would be, initially it was 2, now it would be 1 because it would be decremented by 1. Because now once this weight of F is successfully executed, in that case it would be will decrement the value by 1. Okay. Now next is weight on S. Weight on S. Why we are doing weight on S? Because previous value of S was 1, so we are doing 0 over here. Why? Because while a consumer doing its task, okay, no other process can continue its task, or no other process can enter into critical section. So that is the reason why we are reducing the value of S by 1. So now it is 0. Then now this consumer will delete that element Y from the buffer or this array. Okay, then once it is deleted, then signal on S will be performed. So means what, now if any other process wants to do insertion or deletion, they can do. So that is the reason why we have executed signal on S. So now S becomes 1. Now the next statement is signal on E. E means what? Empty slots. Now the empty slots are what? Instead of 3, earlier it was 3. Now in this case, by deleting the Y element, now the E value would be 4. Yes, because now we have 4 empty slots. Okay, so this is all of consumer logic. In this way, a consumer works to delete certain elements from the array, or can say consume something from the buffer or can say array. Okay, now still 2 conditions we need to check as far as producer and consumer problem is concerned. One is underflow and second one is overflow. So first of all, we are going to discuss underflow condition. So what is underflow condition? So underflow condition we need to check at the time of consumer logic. When the consumer is consuming something, at that time before executing that task, consumer has to check is there any element in the buffer or not. If there is at least one element in the buffer, then the consumer can consume it. Yes, so that underflow condition we need to check. So what was the initial condition? As far as underflow condition is concerned, E is nothing but empty slots. There are 5 empty slots we have. So all are initially empty. So 5 is the value of E semaphore. S is nothing but 1 and F is nothing but 0. F is nothing but full slot. So there is no full slot. So in this case, what will happen? If you are talking about if you we need to check underflow condition by having this initial value of semaphore. Can we execute the consumer logic? Let us check. So first statement is what? Wait on F. Wait on F. Can we execute wait on F? Because the value of F is already 0. So we cannot reduce the value of F. So that is the reason why if we do not have any element in the buffer, we cannot execute the code of or logic of consumer. So this underflow condition is satisfied by having this logic. Same way we are going to discuss the overflow condition. So while producer producing some things, let us discuss if all the elements are, all the cells are occupied in the array or in buffer, like A, B, C, D, E in this case. So what will happen in this case? And initial value of E is nothing but, is there any empty slot? No. So initial value is 0. S is nothing but 1 to achieve critical section problem, and F is nothing but full slot. How many full slot we have? 5. Yes. So all are occupied. So let us check overflow condition. Can we execute the logic of producer if we do not have any empty space in a buffer? So let us check. So first statement is what? Wait on E. But value of E is already 0. So we cannot reduce the value of E if the initial value of E is 0. Yes. So we cannot insert any element if the buffer is full. So means what? By having this logic, we can also check overflow condition as well. Yes. So in this way, you can avoid the problem of producer consumer. We solve the problem of producer consumer, which is nothing but one classical problem of process synchronization with the help of semaphore. So I hope it was clear to you. Thanks for watching this video. See you in the next one.